Testing by itself is quite the endless topic that could be fragmented into many separate videos. Since we can't really cover every aspect of testing itself, we'll be focusing primarily on how testing works within Nest.js. We'll be focusing mainly on tips and tricks, showcasing some best practices, and go over how you can add and manage tests in your Nest applications. For unit tests in Nest.js, it's a common practice to keep the spec files in the same folder as the application source code files that they test. Each controller, provider, service, etc. should have its own dedicated test file. The test file extension must be .spec.ts. This is so that integrated test tooling can identify it as a test file with test suites. For end-to-end tests, these files are typically located in a dedicated test directory by default. End-to-end tests are typically grouped into separate files by the feature or functionality that they test. For end-to-end tests, the file extension must be .e2e-spec.ts. While unit tests focus on individual classes and functions, end-to-end tests are great for high-level validation of the entire system. End-to-end testing covers the interaction of classes and modules at a more aggregate level, closer to the kind of interaction that end users will have with the production system. As an application grows, it becomes hard to manually test the end-to-end behavior of each API endpoint. Automated end-to-end tests help us ensure that the overall behavior of the system is correct and meets project requirements. To better understand how tests look and how they work, let's open up the coffee service spec file we haven't looked at yet and walk through everything step by step. First, we can see that the describe function that defines a block which groups together several related tests. In this case, the describe block is grouping all of the unit tests that concern coffee service class. Inside this block, we could see the before each function. This function passed into the before each hook will be executed before every test. This is typically referred to as the setup phase. Often while writing tests, we have some setup work that needs to happen before each test runs. And sometimes you need to do something after each test runs. Just provide several other helper functions to handle situations like this. We know before each now, but the other available options are before all, after each, and after all. So looking at this test file, let's dive into the before each function call here to see what it's doing. At a very high level, we can see that we're instantiating some type of module by compiling a test module and then utilizing this module to get a hold of the coffee's service. Then it looks like we're storing it in this service variable to be used within our individual tests inside of this describe block. Let's start by analyzing everything that's happening here. The test class is useful for providing an application execution context that essentially mocks the full Nest runtime, but gives you hooks that make it easy to manage class instances and do things like mocking and overriding aspects of your application. The test class has a create testing module method that takes a module metadata object as its argument, the same object we pass into our module decorators. One important thing to note here is the compile method. This method bootstraps the module with its dependencies, similar to the way we bootstrap our application in our main.ts file with nestfactory.create. The compile method returns a testing module instance, which in turn gives us access to a few helpful methods. Once our testing module is compiled, we can retrieve any static instance declared within the module by using the get method we see being used here. As we can see, we're calling the get method here to retrieve our coffee service from within our compiled testing module, and then storing it in the service variable defined within our describe block. This is a standard practice for testing that allows us to store and use this service within all of our tests that are a part of this describe block. Just as a side note for future reference, if you need to retrieve request scope or transient scoped providers, use the resolve method here instead of get. The next big area in our test file is the IT function call. An IT function represents an individual test. In this automatically generated test, there isn't much going on. The test is currently just checking whether the service variable is defined or not. If the service isn't defined, the test fails. Alright, so let's run this particular test file and see if our one test passes or fails. Let's open up the terminal and run the following command. npm run test watch -- space and then coffees.service. The test watch script will run our unit tests in watch mode, automatically rerunning tests on any file change. We're passing in coffee's service here for example's sake, just to indicate that we want to only run the test for this specific file. Typically, we won't need to do this. After running the script in our terminal, it looks like the testing module couldn't bootstrap properly and it's throwing some errors. But what happened? Since the coffee's service class depends on many other database-related providers like connection or entity repositories that are not registered in the testing module, Nest throws the Nest can't resolve dependencies error. So how can we fix this? Let's head back to our testing file and look at the module's metadata again. Our testing module consists of only one provider, which is coffee's service. In theory, to fix the error, we could just add the required providers here into the providers array. However, this would be against best practices and the general philosophy behind unit tests. Unit tests should be performed in isolation, but that doesn't necessarily mean complete isolation. By isolation, we mean that a test shouldn't rely on external dependencies. One philosophy for unit testing is to mock everything in situations like this, but that often leads to fragile tests that are hard to maintain and don't bring any significant value. Our coffee service depends on database-related providers, but the last thing we want to do is to instantiate a connection to a real database just to perform unit tests. So what other options do we have? Without needing to create complicated mocks or connecting to a real database, all we really need to do is make sure that all the requested providers are available to the testing module. As a temporary solution, let's provide all the classes our coffee service depends on using the custom provider syntax. We need to provide connection and our two entities using the getRepositoryToken function, making sure to import it from nest.js type-orm package. GetRepositoryToken accepts an entity, in our case, flavor and coffee, as an argument and returns an injection token. For now, let's just give all of these providers an empty object for a value. Once we start testing specific methods, we'll replace these empty objects with mocks. Let's save everything and open up the terminal again to see if these changes worked. As we can see, the testing module was properly bootstrapped now, and our basic generated test doesn't fail anymore. Great! But we still have plenty of work to do in the following lessons.